For trigonometric substitutions, why is it that when we have a squared minus u squared, we let u be a sine theta, and when we have u squared minus a squared, we let u be a secant theta, and when we have a squared plus u squared or u squared plus a squared, we let u be a tangent of theta. Keep in mind that u can be a function of x, and so u doesn't have to be x. The reason why we let u be certain trigonometric functions is because of the relationship that we see in a right triangle. If we have an a squared minus u squared, then using the Pythagorean theorem, the hypotenuse has to be a, and therefore one of the remaining sides have to be u. It doesn't really matter which one it is. Notice that if we have the hypotenuse being a and the opposite to the angle theta be u, then the remaining side is the square root of a squared minus u squared. With this right triangle, we see that sine of theta equals u over a. Therefore, u is a sine of theta. If we were to label our triangle so that this side is u, then the remaining side has to be the square root of a squared minus u squared. And in this case, cosine of theta is u over a. And so instead of let u be a sine theta, we could also let u be a cosine theta, and it will work. By convention, we use sine. And so if we have a squared minus x squared, then that is the reason why we let x be a sine theta. Similarly, with u squared minus a squared in the integrand, we draw another right triangle, and we see that if we label one of the angle theta, with u squared minus a squared, u is more than a, and with the Pythagorean theorem, u had to be the hypotenuse, being the longest side. One of the other sides had to be a, and therefore the remaining side is u squared minus a squared, the square root. From this, we see that cosine of theta is a over u. Therefore, a equals u cosine theta, but u is therefore a over cosine theta, but 1 over cosine theta is secant theta. And that is the reason why we let x be a secant theta. And with the last case, because of a squared plus u squared, a and u have to be the size of the legs, and therefore the hypotenuse is the square root of a squared plus u squared. We see from here that tangent of the angle theta equals u over a, and so u is a tangent of theta. And so by looking at the expression in the integrand, you can draw a right triangle and label the sides appropriately, whether a being the largest length or u be the largest length, or a and u be the two sides. You can get the trigonometric function of theta from there. And so the convention is that we let u be a sine theta, u be a secant theta, and u be a tangent theta. But there are alternative setups, just like the case where we let u be a sine theta. It would work if we let u be a cosine theta as well.